Hello students, welcome back to my fifth lecture on basic maths. In our last lecture, we dealt with determinants, its properties with 2-3 examples. Next, we will move to 3 marks question under the properties of determinants. So let us solve the first problem. Prove that determinant of 111 ABC a square b square c square is equals to a minus b into b minus c into c minus a. How to choose the row operation or column operation depends on the RHS that you want to prove. Carefully look at the RHS part and decide what operation can be used here. Observe, you need a minus b in the first part and b minus c in the second part and c minus a in the third part. So if you subtract first column with second column, you get the first part, that is a minus b. If you subtract second column with third column, you get b minus c. Similarly, if you subtract third column with the first column, you get third part, that is c minus a. You can do two operations simultaneously. We are now using the operation column 2 minus column 1. Similarly, column 3 changes to column 3 minus column 1. If you do this, you get determinant of first column keep as it is 1a square. We are changing second column and third column simultaneously. Two operations we are changing. So if you subtract second column with first column, you get 1 minus 1 is equals to 0, b minus a, b square minus a square in the second column. And third column changes to third column minus first column, that is 1 minus 1 is 0, c minus a, c square minus a square. Fine. Now keep the first column as it is in the third determinant and you can simplify b square minus a square as b minus a into b plus a. Similarly, c square minus a square can be simplified as c minus a into c plus a. Whatever remain common in the entire row or column, we can take it out. That is b minus a in the second column and c minus a in the third column can come out as a common term. So you can take it out and what remains we will keep it as it is in the respective determinant. So that is b minus a into c minus a under the determinant. First row will remain as it is 1 0 0. Second row will be a 1 1 and third row will be a square. B minus a is already outside, so b plus a will remain and c minus a is outside as a common part, c plus a as a last element. Now look at the RHS. You are successfully in getting RHS. If you evaluate the determinant, you will get the another part, that is a minus b. C minus b. So we will start the expanding. Keep b minus a, c minus a as it is. in the evaluation part, 1 into delete the first row and the first column, multiply diagonally the second column with the third column. It will become 1 into C plus A minus 1 into B plus A minus, here in second column there is a 0. So 0 of anything will be 0 only. Similarly, in third column again there is a 0 in the first row. So 0 of anything will become 0 only. So they have done it directly. So next one, that is equals to B minus A into C minus A into, open the bracket, it will be C plus A minus B, plus of minus is minus, minus A. So plus A minus will be get cancelled. So what remains? C minus B. So here B minus A can be interchanged to get the exact RHS. So that will be, take minus outside, A minus B, keep C minus A as it is, again change C minus B to B minus C by multiplying it by minus 1. Next, minus 1 will become plus 1. So you get A minus B, B minus C into C minus A, which is the required RHS part. So we have proved what they have asked. We will move towards the next sum. Similar sum show that the determinant 1, 1, 1, A, B, C, A cube, B cube, C cube, which is equals to A minus B, B minus C, C minus A into A plus B plus C. Exactly from the previous example, we'll take the same property. That is, change column 1 to column 2. Column, we can do two operations simultaneously. That is, change first column and second column. Keep third column as it is. Check the RHS and decide which property is more suitable. So first column we are changing, that is C1 changes to C1 minus C2. Therefore, here it will be, first column you observe students, 1 minus 1 is 0, A minus B, A cube minus B cube. Similarly, second operation, second column changes to C2 minus C1, C2 minus C3. So 0, 1 minus 1 is 0, B minus C, B cube minus C cube. So we are doing two operations once only simultaneously. So keep third column as it is, 1 C, C cube. Next, simplify A cube minus B cube as A minus B into A square plus AB plus B square. Similarly, simplify B cube minus C cube as B minus C into B square plus BC plus C square. Now, here in the first column, A minus B is common. There is a 0 in the first row, 0, 0, 1. Don't worry about that. 0 into A minus B will be 0 only. So you can assume that there is a minus B common in the first column. 0 into A minus B. Similarly, in the second column, b minus c into 0 is 0 only. So here also you can assume that there is a b minus c in the second column, first row. Now, so a minus b is common from the first column, take it out. B minus C is common in the second column, take that also outside. Then evaluate the determinant. So you get 0 of anything will be 0. So first column contains 0, second column contains 0. So directly you can move towards the third column. So that is 1 into, delete the first row and the third column and multiply diagonally. You get b square plus bc plus c square into 1. As a minus b we have taken outside, you get 1 over there, minus a square plus ab plus b square. Next step, a minus b, b minus c as it is, into, here if you open the common bracket, you get c square minus a square plus bc, and here b square minus b square will get cancelled, then minus ab will remain. Next, a minus b into b minus c into, here c square minus a square can be written as c minus a into c plus a, plus b is common in the last two part, that is b as outside common term into c minus a. Again, last but one step, a minus b into b minus c into c minus a into, there is a common term c plus a so take it outside, c plus a plus b. So you will get a minus b, b minus c, c minus a into a plus b plus c. There is already c minus a outside. So you take c minus a outside and you will get inside as a plus b plus c. So this is your required RHS part. So students, you please write it 2 times, then you will understand better. So next question, next example, prove that in the determinant 1 plus a, b, c in the first row, a, 1 plus b, c in the second row, a, b, 1 plus c in the third row, which is equals to 1 plus a plus b plus c. So now take LHS part, and students just check the RHS and decide which property is suitable to get the RHS. So if you add first column, second column and third column, you will get the required RHS. Yes or no? So that is equals to, change the first column itself, add first column with second column and third column. Only one operation we are doing here. That is equals to, in the first column you get 1 plus a plus b plus c. Second row you get a plus 1 plus b plus c. Third row a plus b plus 1 plus c. Second and third column keep it as it is. Now in the first column there is a common term, that is 1 plus a plus b plus c. you can take it outside, and in the determinant, in place of 1 plus a plus b plus c, you can write 1 1 1 in the first column, remaining 2 columns as it is. Now we can change second row to first row, so that we need to get the whole determinant equals to 1. That's why make the determinant equal to 1 to sustain the RHS part as it is. We already got it as it is. Just we need to prove that the determinant equals to 1. Therefore, change R2 row 2, that is equals to R2 minus R1. Similarly, third row operation, that is R3 minus R1. Therefore, we are not doing anything with the first row. Keep as it is 1 B C, and second row will be 1 minus 1 is 0, 1 plus B minus B is equals to 1 only, B will get cancelled, and C minus C is 0. Similarly, third row will be 1 minus 1 is 0, R3 minus R1, B minus B is 0, and 1 plus C minus C is equals to 1 only. Fine. Now, here, since we are using the 8th property, what 8th property will say? If 3 zeros beside the diagonal element are equals to 0, then multiply the diagonal elements. That is, write down 1 plus a plus b plus c, and here see, you can observe after diagonal, the below continuously 3 zeros we can see. So multiply 1 into 1 into 1, read the third property, sorry, 8th property. So you get the diagonal elements, product of diagonal elements is equals to 1. So that is equals to 1 plus a plus b plus c. So which is the required RHS. Next question. Prove that the determinant x p q first row, p x q second row, p q x third row, which is equals to x minus p, x minus q, x plus p plus q. So here see the RHS part. We must get x minus p in the first part and x minus q in the second part, and third part x plus p plus q. So first we will just observe the determinant part carefully. Here in the third part we must get x plus p plus q. We get this if we'll add the first column with second and third column. So that operation is C1 changes to C1 plus C2 plus C3. That's equals to x plus p plus q in the first column. Second column keep as it is, even third column also keep as it is. In the next part, x plus p plus q is common. You can take it outside as a common part. So in place of first column, write down 1 1 1. Keep second and third column as it is. Fine. Now take R2 changes to R2 minus R1, and the second operation R3 changes to R3 minus R1. To get x minus p and x minus q, we are doing these two operations again. Therefore, that is equals to x plus p plus q determinant into determinant 1. First row changes to 1 p. We are not doing anything with the first row. Second row will be r2 minus r1, that is 1 minus 1 is 0, x minus p, q minus q is 0. Similarly, r3 changes to r3 minus r1, that is 1 minus 1 is 0, q minus p, x minus q. If you evaluate the determinant, so column wise also we can evaluate. 1 into delete the first row and first column and multiply the diagonally of second column and third column, that is x plus p plus q into 1 into x minus p into x minus q. Minus 0 of anything will be 0 only. Next, here 1 into x minus p is x minus p only into x minus q. So, which is the required RHS? Next sum. Show that the determinant 0 a b square a c square in the first row, a square b 0 b c square in the second row, a square c b square c 0 in the third row, which is equals to 2 times a cube into b cube into c cube. Here observe carefully, students. There is a common terms in row wise also and column wise also. So select, take a square b square c square as common from first column, second column and third column. So if you take these outside, the determinant will be 0 a in the first row, in the second row b 0 b, in the third row c 0. That is equals to, since we have taken a square b square c square common, again from first row we can take a common, second row we can take b common, third row we can take c column. If you do so, you get the determinant 0 1 1 1 0 1 1 1 0. That is equals to, here you can multiply the first bracket with second bracket, you get a cube b cube c cube into c. First element in the determinant itself is 0. So 0 of anything will remain 0 only. So leave that. Take the second part minus 1. If you evaluate this, minus 1 into 1 into 0 is 0, minus 1. Then third part 1 into 1 is 1 only. Hence, if you evaluate the determinant, you get 1 plus 1. That is equals to 1 plus 1 is 2. You get the required RHS. Next sum. That is, this is from the exercise. Important sum. They have asked this many times in the examination. Prove that 1a bc in the first row, 1b ca in the second row, 1c ab in the third row is equals to a minus b into b minus c into c minus a So the answer will be, what operations is suitable here? Row operation. Why? Because there is a in the first row, B in the second row. If you subtract the second row with third row, you get the second part. Third row with the first row, you get the third part. So choose the operation carefully. So here I am not doing anything with the first row, kept as it is 1A BC. Second operation changes to second R2 minus R1. You get 1 minus 1 is 0, B minus A, and B CA minus BC. There is a C common, so inside the bracket you get A minus B. Similarly, second operation, that is R3 changes to R3 minus R1. So 1 minus 1 is 0, C minus A, B is common in AB minus BC. So take B outside. Inside you will get A minus C. That's equals to, in the second column there is a, in the second row there is A minus B common. You can take it outside. Third row there is a C minus A common term. You can take it outside. So you get the determinant part. A minus B into C minus A in the determinant 1, 0, 0. A, B minus A, we have taken common it as A minus B. We have reversed it, sign will change. So you can write minus 1 over there. And in the second row C will come. A minus B is outside. So you can write C. So C minus A, we have taken it outside. 1 you will get in second column, third row. And last term is A minus C, we have taken common it as C minus A. So sign will change as minus B. In the next part, say take the next operation, that is R3 changes to R3 plus R2. Why? Because we got A minus B common term. See the RHS part, C minus A. Now we must get B minus C. How we will get? If you will add third row to second row, we get B minus C. So we will try that. So keep first row as it is, second row also as it is. We must get B minus C. So we are choosing the third row. We are adding third row to second row. So 0 will remain as it is, third row. 1 minus 1 is 0 and minus B plus C. So you also can write this as C minus B. Now that is equals to A minus B. See here, C minus A, we must get it as A minus C. So you can change that also. B minus C. So that is your required RHS part. I hope you understood this. Next sum. Prove that the determinant B plus C, A in the first row, B, C plus A, B in the second row, C, A plus B in the third row should be equal to 4 times A into B into C. Here. So you have to use the operation as R1 changes to R1 minus R2 minus R3. You have to reduce any row or any column. So it becomes B plus C minus B minus C. First row only we are changing. A plus A minus C minus A minus C, and third column changes to A minus B minus A minus B. Second row, third row, keep it as it is. Then here B plus C minus B minus C will become 0. All the elements will get cancelled with the opposite elements. So first element will become 0. B, C in the first column. Second column will be A and A will get cancelled. Minus C will be minus 2C. So C plus A, C is the second column, and third column will be minus B, that is minus 2B, B, A plus B as third column. Now, if you will expand the determinant, 0 of anything will be 0. So, ignore that column only. Then, minus of second column we are operating, minus of minus 2C into product of first with third column, that is B into A plus B minus BC, plus of minus 2B into B into C BC minus C plus A into C is C square minus AC. That is equals to, simplify the previous step, that is minus into minus will be plus 2C into AB plus B square minus BC, plus of minus is minus 2B into BC minus C square minus AC. Now, open the bracket and multiply with their coefficient. You get 2 into ABC plus 2 into B square C minus 2 into BC square minus 2 into B square C plus minus into minus will be plus. There is a minus 2B. Minus 2B into minus C square will be 2BC square plus 2B minus 2B into minus AC is 2ABC. Check the common terms with opposite signs. Here 2B square C plus 2B square C will get cancelled with minus 2B square C, and minus 2BC square will get cancelled with plus 2BC square. Now what remains? Plus 2ABC plus 2ABC. If you add these two terms, you get 4ABC. Next example. Evaluate the determinant. Here they have asked to evaluate, not show that. So evaluate in the sense here you have to find the value of x. That is x minus 1, 1, 1 in the first row. In the second row 1, x minus 1, 1. In the third row 1, 1, x minus 1, which is equals to 0. So here to find this value we have to eliminate some terms. We have to operate with the R1 changes to R1 plus R2 plus R3. Keep second row, third row as it is. So you get first row changes to first row, add first row, second row, third row. You get x minus 1 plus 1 plus 1. Minus 1 plus 1 will get cancelled. In the first row you are going to get x plus 1, x plus 1, x plus 1 only. Keep second and third row as it is. Then x plus 1 is common from first row, you can take it outside. In the bracket, in the determinant, the first row will become 1, 1, 1. Keep second and third row as it is. Now, change second row, that is, second row changes to R2 minus R1. It will be, first row keep as it is, 1, 1, 1. And R2 changes to R2 minus R1. That is 1 minus 1 is 0. X minus 1 will be x minus 2. Then 1 minus 1 is 0 again in the second row. And third row changes to R3 minus R1. It will be 1 minus 1 is 0. 1 minus 1 is 0. X minus 1 minus 1 will be x minus 2. Okay. Now, using the eighth property, the product of the diagonal elements will be a 1 into x minus 2 into x minus 2, that is x minus 2 the whole square. We are using eighth property here. Beside the leading elements, if 3 continuous zeros will be there, then product of leading elements have to be done. That is x plus 1 into x minus 2 the whole square is equals to 0. So, first compare x plus 1 with 0. You get the value of x is equals to minus 1. Otherwise, x minus 2 the whole square equal to 0, equate it to 0. So, you get x minus 2 the whole square equal to 0. So, squaring both the sides, then shifting minus 2 that side, you get the value of one more x, that is equals to 2. Okay. So, with this I have completed the third 3 marks questions which are going to appear in the examination. Hope you understood. Maintain a book properly, write the operations properly and practice it. So, we will meet in the next class. Thank you.